Welcome to this introduction on grape maturity. Grape maturity is one of the most critical factors influencing wine quality. The moment we choose to harvest determines the balance between sugar, acidity, aromas, color, and tannin structure. In fact, each type of maturity contributes differently to the final wine style. In this video, we'll explore three essential concepts: technical maturity, aromatic maturity, and phenolic maturity. Understanding these three dimensions is fundamental for making informed decisions, both in viticulture and winemaking. So, let's begin by looking at these three complementary types of maturity. The first one is technical maturity. This stage is reached when the grape shows an optimal balance between sugar accumulation and acid degradation. It is the most commonly monitored type of maturity in vineyards, mainly because it directly affects potential alcohol, freshness, and microbial stability. To evaluate technical maturity, we monitor several analytical parameters such as sugar concentration, pH, total acidity, and sometimes berry weight. Together, these indicators help us determine whether the grapes are suitable for the wine style we want to produce. Now, let's move on to the second type of maturity: aromatic maturity. It refers to the development of aroma compounds and their precursors in the grape. It is highly dependent on grape variety and environmental conditions. Importantly, aromatic maturity does not always occur at the same time as technical maturity. Grapes contain both free aroma compounds and non-volatile precursors. For example, in Sauvignon Blanc, thiols give typical tropical and citrus notes, such as passion fruit and grapefruit. These thiols often exist as precursors that are released during fermentation. In Muscat varieties, terpenes dominate the aromatic profile, producing characteristic floral and fruity notes like rose and lychee. Here, their concentration and balance define the aromatic potential of the future wine. Aromatic development is also strongly influenced by viticultural practices and environmental factors. Sun exposure, water availability, and temperature all affect the synthesis or degradation of aroma compounds. This is why canopy management plays such a key role in controlling these parameters. Finally, let's look at the third type of maturity: phenolic maturity. It refers to the ripeness of tannins and anthocyanins. It determines both the extractable quantity of anthocyanins and tannins and the quality of tannins, which influence a wine's color, structure, and aging potential. It's also important to bear in mind that phenolic maturity doesn't always occur at the same time as technical or aromatic maturity. Tannins evolve significantly during the ripening process. Seed tannins become less bitter and less astringent as they mature. At the same time, skin tannins also change in structure. Together, these transformations influence the tactile sensations of the final wine. Anthocyanins are the pigments responsible for the color of red wine. Their concentration increases early during ripening and then stabilizes. However, their extractability depends on cell wall degradation, which is linked to phenolic maturity. Before we go deeper into the different types of grape maturity, it is important to understand where the key compounds are located within the berry. Technical maturity essentially reflects the maturity of the pulp, as sugars and organic acids are found almost entirely in the flesh of the grape. As the pulp ripens, sugars accumulate and acids decrease, directly influencing potential alcohol and acidity in the future wine. In contrast, aromatic maturity and phenolic maturity are linked to the maturity of the skins and seeds, which represent the solid parts of the grape. This is where we find most aroma compounds, aroma precursors, tannins, and color compounds such as anthocyanins. So in short, technical maturity is driven by the pulp, while aromatic and phenolic maturity depend on the ripeness of the skins and seeds. Understanding this distribution helps explain why these maturities do not always evolve at the same pace. As a result, harvest decisions involve finding the best compromise based on the desired wine style. For example, aromatic whites may be harvested earlier, while red wines often require advanced phenolic maturity. Let's take an example. We don't harvest at the same moment if our goal is to make a rosé wine or a red wine. Rosé wines typically require higher acidity, lower sugar levels, and fresher aromatic profiles. This means the grapes are harvested earlier, when the pulp still contains more organic acids and the pH is lower. This ensures a bright, crisp, and refreshing wine. In contrast, red wines benefit from lower acidity, higher sugar concentration, and especially greater phenolic maturity. To achieve this, grapes are harvested later, allowing more time for sugar accumulation in the pulp and for tannins and color compounds to fully develop in the skins and seeds. This later harvest supports deeper color, rounder tannins, and a fuller body in the final wine. To summarize, technical maturity focuses on sugars and acids, aromatic maturity on aroma compounds and their precursors, and phenolic maturity on tannins and anthocyanins. Understanding how these different types of maturities evolve helps us choose the optimal harvest moment for the intended wine style. And ultimately, the objective remains the same: crafting wines that truly seduce wine lovers.